Hi, in this video I'm going to show you how to convert denary numbers into binary numbers. Denary numbers work on something called a base 10 system, so there are 10 digits in the denary system: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and all numbers in the denary system can be made up of a combination of those 10 different digits. Binary is different. Binary is a base 2 number system, and there are only two values in the binary system: zeros and ones. So computers work primarily with binary numbers, so it's important you have an understanding as to what a binary number looks like and how we can convert denary into binary, because in a later video we're going to look at how we use binary numbers to identify a key press on the keyboard, and you're going to use some of your skills to decode a message. So let's start having a look at this then. So if you look at the grid that's in front of you, you can see that we have a number system here. Okay, I've just highlighted that on the screen, and that goes from 1, 2, 4, 8, 16, 32, 64 and 128, and you'll notice that those numbers double. Okay, so what we're going to do is to work from the left hand side. So we start with the biggest number, and we're going to convert this 54 into a binary number. Okay, you'll see there's 8 empty squares. That means this is an 8-bit number. So computers tend to work on either 8, 16, 32 or 64-bit. Okay, so that means the size of the binary digit. So this is the smallest that we would use in a computer system, which is 8-bit. So let's start looking at this then. So what we're essentially doing is we're comparing the number that we're trying to convert with the numbers in here. So we're looking to find out whether 54 is bigger than or the same as a particular number. So we start on the left hand side. So let's make a start. So is 54 bigger than or the same as 128? Well, it's not bigger, okay, and it's not, so we're going to put a 0 in there. So we move to the next one. Is 54 bigger than or the same as 64? No, it's not. So that is also a 0. Is 54 bigger than or the same as 32? Yes, 54 is bigger than 32, so that is a 1. Okay, and what we do then, we start subtracting the two digits. So we've got our original number of 54, okay, and what we're going to do, we're going to subtract the 32 that we've just got, okay, and then we're going to work out the answer. So 54 minus 32 is 22. So now we're working with 22. So we're looking at the next cell. So is 22 bigger than or the same as 16? 22 is bigger than 16, so that's a 1 in there as well. Okay, so we're now going to take away 22 minus 16. Okay, and that's going to give us 4, 6. Okay, so now we're looking at this number. So is 6 bigger than or the same as 8? Well, it's not, so there's a 0 in there. So we move on to the next number. Is 6 bigger than or the same as 4? 6 is bigger than 4, so we've got a 1 in there. We've run our calculation at the bottom again. 6 minus 4, okay, and that equals 2. So then we're working with 2. Is 2 bigger than or the same as 2? It's the same. So the 1 goes in there, and now we're working at the last part of our calculation. 2 minus 2 is equal to 0. Okay, so once we get to the point where we've got 0, everything else to the right of the number we're working on is a 0. So 54 in binary is 0, 0, 1, 1, 0, 1, 1, 0. So that's how you convert denary numbers to binary. So I'm going to work through one with a slightly larger number in this one. So same principle. So is 187 bigger than 128? Yes, it is. So then we're going to go on to our calculation. So it's 187 minus 128. Okay, and that's going to give us 59. Okay, so is 59 bigger or the same as 64? It's not. Okay, so we go on to the next number. Is 59 bigger than or the same as 32? It's bigger, So we're going to put a 1 in there, and then we're going to go on to our calculation. 59 minus 32, that's going to equal 27. So is 27 bigger than or the same as 16? 27 is bigger, so there's a 1 in there. So we're going to work out 27 minus 16, which leaves us with 11. Okay, is 11 bigger than or the same as 8? It's bigger than 8, so we put a 1 in there. And now we're going to do 11 minus 8, which gives us 3. Is 3 bigger than 4? No, it's not. Is 3 bigger than 2? Yes, it is. So we put a 1 in there. And then we're going to go 3 minus 2 is equal to 1. And is 1 bigger than or the same as 1? It's the same. So we got a 1 in there. And just to round off the calculations, we're going to put 1 minus 1 equals 0. Okay, so 187 in binary is 1011111. So that's how you calculate or you convert denary numbers into binary. And with an 8-bit system, you can convert up to a number up to the size of 255. Anything over that, you need extra bits. Okay, so that's how you convert denary numbers into binary numbers.